Before heading to the video, if you haven't subscribed the channel, do subscribe it and don't forget to click the bell icon for the latest update notification. If you like the video, do like, comment and share. Stay tuned with Learnbay.co. Happy learning!
So if you have X and Y, and let's say you have collection of points. So basically, fundamentally what you want to do here is, you want to kind of estimate this function so that in future, if I may ask you, where should be the point here, 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 you will be able to give me a better estimate where should be the next or the future prediction would be. Okay, so if I were to take some new value of X, I can just plot it against the function that I have estimated, and I can say, okay, this would be the new Y value or the expected Y hat, right? But not all problems come in the kind of same flavor, right? So if there is regression, there is another problem as well. So regression is like numerical regression. Like based on X or set of Xi, you have to tell Y, which is just continuous. Okay, but what if Y is discrete? Okay, first, what is discrete? Discrete variables are
known. Which are countable.
Sorry, I did not get you. Can you say that again?
Which are countable.
Countable, very good. Examples?
Dice, rolling a dice.
Okay, outcome of a die.
Yeah.
Time on a digital clock.
Sorry, what did you say?
Time on a digital clock.
Time on a digital clock. Okay, okay, good answer. Although time itself is a continuous value, but you can think like if you can sample it perfectly, it can be treated as continuous. Sorry, discrete, my bad. Okay, what are other examples? So, one second. Okay, what do you think about classification? What does comes to your mind when I say the word classification?
Grouping based on certain characteristics, maybe?
Grouping based on characteristics. Okay, wonderful. Let's see. Organizing in groups. Yeah, so everyone will go for this idea that fundamentally there are groups. And basically, rather than trying to point or come up with a numerical answer or numerical continuous value, you are trying to kind of put it like in different groups, like let me plot something. So maybe there is a group for vegans. Maybe there is a group for vegetarians, non-vegetarians. Okay. Now, based on everyone's food preferences, you want to say who is where. Okay. This could be a good example of classification. What could be another example of classification?
Income groups.
Very good. Income groups. Yeah. So we have ultra rich. Okay. Basically, and then you have fundamentally rich people. Now this could be also like subdivided. Okay. And then you have middle class. And now middle class can also be divided like upper or lower. And then you have a lower class. So there could be different income groups based on their spending or their earning. So in industries or even in corporations, there are like a lot of problems which can very easily fall under, yeah, thanks, uh, fall under classification problems like credit risk analysis. So you have to worry about people who are uh, high risk. Okay, someone could be a low risk as well. So it could be just categorization. You could have a diagnosis of a tumor, which could be benign or malignant. You understand the difference between benign and malignant? What is a benign tumor? What is a malignant tumor?
Benign is not harmful, right?
Right. Benign is something that is not harmful, and malignant is
Harmful.
harmful, which can basically develop into cancerous cells or tissues, basically. So basically, when you are trying to do a tumor diagnosis, basically one of the symptoms or the way you identify there might be cancerous or cancerous cells, there is a tumor developing over in that area, and basically by taking a small biopsy, means they will take a very small part of the muscle or the tissue from there, and under analyzing it, they will try to kind of diagnose it into a benign or a malignant tumor. So if it is benign, there is not much problem, but if it is malignant, then it could be a serious problem. Okay. So similarly, in real world, there are a lot of problems where you want to classify the incoming data points or the new data points based on certain classification, or you just want to group them in their respective categories and treat them as such. Okay. So fundamentally, if I had to define classification, how would I define? Classification is a problem of identifying to which of a set of categories or subpopulation a new observation belongs on the basis of training data of data containing observations whose category membership is known. Of course, we are dealing in supervised set. So classification mostly means supervised, okay? For unsupervised, we mostly say clustering. So let's say you have two groups, apples and oranges. So if a new point comes, then what group is this? Most probably, most people will say it is on orange, and you will not be really wrong here, right? And you can see when you are using some linear discriminant. So if someone says discriminant, understand they're talking about basically a line which is gonna classify, or they could be talking about curves which classify basically. Okay. In a very simple term, this is how it could look like. You could have a binary classification, 0, 1, true or false, spam, not spam, benign, malignant. But you could have multi-classification as well, where you could have vegan, vegetarian, non-vegetarians. Okay. So one sec. Okay. Ponder on this question. Why can't we use linear regression for this use case? I'll be back in a moment. Okay. Yeah, any idea? Why can't we use linear regression for a classification problem?
Because for linear regression, we need continuous, yeah? Continuous data points.
That's all right. That's all right. So let me ask you like in this fashion. Maybe this might help you. So if I had two groups or subgroups, let me say subgroups. Okay, this will be better. Okay, and the other group is this one, not this one. So why can't I take a line? Think about it. Draw through them, and then basically based on certain threshold, do a division. Wouldn't that work? Is from here you can see like these two groups are separated already. So I can say from here there's a different class in the line. What is the problem in this case?
Is there too much bias in it?
Bias as in?
Not sure.
Okay. Okay, so the fundamental problem is the issue of outliers. Just putting few outliers, what it can do is it can shift the line. Okay. Now, based on this line shifting or the way, any way you want to imagine, it can hamper the cut or the threshold. And based on that threshold, some points may start to get misclassified extremely fast. So the problem is because of mean squared error, if you have outliers, then this trick won't work. Okay. So you cannot just like cut a threshold and you will like, okay, yeah, from here, this class A and there is class B. It won't work if you have outlier scenarios. Okay. So we come to a problem called, or sorry, a technique called logistic regression. So fundamentally, logistic regression was developed by statistician David Cox back in 1958. And fundamentally, the binary logistic model is used to estimate the probability of binary response. Remember, in its truest sense, logistic regression actually just returns the probability, okay, not the classification, but again, you can infer the classification based on the probability. And logistic regression was and still is used in biological sciences in earlier 20th century, and of course, it has been used in so many different classification problems. Even in risk analysis, a lot of people still use logistic regression. Okay. Now, you might be wondering, what is this logistic? Anyone knows what is a logistic function? Okay, for purpose of statistics, logistic function is same as sigmoid function. Now, sigmoid function is many times represented by sigma, that's x, and the equation is very simple. E minus x. Now my drawing is not that great, to be very honest, but I will try. So it is kind of S-shaped. Okay. So it is defined from negative infinity till positive infinity, but its outcome is between 0 to 1. Okay. You know what? I will show you the slide. My drawing is not that good. Okay, I want you to note down this function and maybe even draw the function if possible. So sigmoid function is a bounded differentiable real function. So remember, it's bounded between 0 to 1. It's differentiable, yeah, it is end-to-end differentiable, and it's a real function, means all the values that it outputs are real. And it is also defined for all real values input and has a non-negative derivative at each point. Sigmoid is synonymous to logistic function, okay? Okay, how do you know something has a non-negative derivative?
No idea, Amtan.
Is it like maybe like when you divide, the outcome is not zero?
Okay, okay, what is derivative? Anyone?
Finding tangent.
Sorry, yeah, tangent, very good. So rather than saying non-negative derivative, if I would have said you non-negative tangent, then what you would have thought about?
So slope will not be zero at any point during this
No,
function.
be careful. I said non-negative. I did not say non-zero. I said non-negative tangent. So it can be zero, okay? But it can't be negative at any moment. So do you realize when the tangent value is sorry, negative? My bad. As you said, tan theta. So do you have any idea when or for what values of theta it becomes negative?
Less than zero.
Okay, or you can go positive as well, less than zero. Okay, so we mostly don't take less than zero or anything in like this coordinate geometry. It means you can take negative, but usually the convention is how, like you go this anti-clockwise, and this is 90 degree, this is 180, this is 270, and this is 360, right? So we basically take a whole circle and we try to keep it positive. Okay, so what happens is tan theta, where theta is somewhere between 0 to 90 degree. Now I'm not sure which one is which. Okay, so tan can range from 0 to, basically it's not defined exactly. Some people will call it infinity as well. And after that, what happens after when it goes greater than 90 degree? You will start to see negative values. Okay, so what it simply means is whenever you are taking a derivative, limit or a line at any moment, I should use a different color. You will see you are only gonna get acute angles. So this is not a very good one. So at any moment, if I were to draw this, you will find I'm only gonna get acute angles. Okay. And these all are acute angles. So acute angles are
0 to 90.
Yeah, very good. Okay, so 0 to 90 or basically anything less than 90 degree, and of course 0 to 90 is 90 is right angle exactly. So these are acute angles. So at any moment in sigmoid, you are not going to get anything beyond even close to 90. Okay, everything is basically acute angle or parallel. So if something is parallel to x-axis, it means theta is 0. Okay, so that's what it means by non-negative derivative. At any moment you differentiate this, you are going to get some kind of a positive value, but you will never get a negative derivative. Let me draw something for you. Y is, let's say, okay, let me put it as true. Okay. Okay. So anything could be this idea, or I can give you a slightly bigger one. So let's say if I wanted to interpret this one. Now it could be anything. I'm not saying it has to be exactly like this, but let's say we have 4 points. So how much is the total dimensionality of this data?
Two
Sorry.
dimension.
Yeah, that is okay. Hold on. So this is your data, okay? So total dimensionality is this is your data, okay? So what is your total dimensionality?
Two dimension.
But how? Just look at your data. How do we determine dimensionality? Does anyone basically understand this?
Just 4 by 3.
Dimensionality.
4/3.
Okay, 4 by 3.
Rows,
That is for
rows and
matrix.
columns.
How
Yeah.
many dimensions it will take to represent all of this information?
It's 4 dimensions, right?
No, that's where you are wrong.
3-dimensional.
4 dimensions. Yes, I might have told you already. So as many columns you have, that many dimensions are there. Okay, so you have x1, x2, and the result, that is y, right? But where is y exactly in this one? Where when I plotted here? Funny thing, I have represented it correctly, but you don't see a y dimension, do you? Very good. Color or different shapes. This is the whole problem. I am representing a 3-dimensional data on a 2-dimension, of course. So if we were to make this 3-dimension, how would it look like? Any idea? So let's say this is your normal 2-dimension. Okay. And then you will have to initiate a new dimension, let's say. That is the 3rd dimension. So your normal data is put here. Okay. Now this is the whole problem. Actually, the data is not like this. This is the whole problem. Now you will have to determine which one gets to be 1, which one gets to be 0. Okay. So let's say this is 1 and this is 0. So how does the data looks like if I were to just do some kind of manipulation so that it is easier for me to draw? It's basically looking like this. Do you understand how did this happen? So basically these red ones are at a plane of 1. Okay. And these yellow ones are at 0 itself. Okay. And they are at different plane. Okay. Now this is the problem that a lot of people actually fail to visualize. Even when I'm showing them through colors, I am actually representing an extra bit of information. Okay, and this, please try to remember this because this will be very important as we go forward. Everyone like get the idea what I'm trying to say here?
I'm sorry, can you please repeat if you don't mind?
Sure, okay. Okay, did you understand how did I represent three-dimensional data or dimension with data with three dimensions on that x1 and x2 axis?
Yeah.
Okay.
In the first one, I was confused because, you know, instead of y, yeah, there was x2, right? So that's why I was confused.
Yeah, so but no, but the data has x1 and x2, so I had to write x1 and x2, of course. So what my point was, even without writing y, a lot of people represent the third dimension. But what happens is people fail to realize the importance of that color. Okay, now you have to imagine if there was a third dimension which is there, okay, and let's say I had to convert them to numbers, okay. So now imagine 0 and 1. So imagine all the red points, because there are different classification or different class, they will be on a different plane, which is y is equal to 1, okay. And all the yellow points are on a different plane. They are on y is equal to 0. That's how you will understand the classification, right? Or that's how you will understand, okay, there are three dimensions. It's just that we took them for granted. We looked at the colors, we understood there are two groups, but we did not think about the mathematical issue, that mathematically how to represent them really. So is everyone clear what am I trying to represent here?
Yes. Then we can also represent any other color in another plane, right? For y's
Yeah,
value
of course,
from
of
0,
course.
0 to any positive value, there are n number of planes, right? Stacked one over
Yeah,
another.
you can have
Then
multi-classification as well. I'm not saying, but let's start with the binary classification because that will be easier for you to understand. Of course, in classification, we do deal with multi-classification where you can have y is equal to 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's okay. But just making you understand that looking at the colors, do not think they are at the same plane. Try to imagine mathematically they are at different planes already. Okay. But now my challenge to you is to use regression. Now you might be wondering, or if you have not wondered, it might be a very good time to wonder. Why it is called regression, logistic regression? Okay. So what is a linear discriminant? Let's talk about it. Linear discriminant. What do I mean by this? Anyone? Again, the very much name says it all anyways, but still I want you to try.
Like function or some parameter that classifies two groups based on a linear dimension.
You're going in the right direction. So
bisection of a
discriminant is something, curve or a line or a curve, which discriminates or separates various groups. But I said linear. So what does linear means? And I have discussed this. What does linear means?
line equation or with the first order?
Equation of straight line basically. Which also means power of maximum power of 1. Okay. So let's talk about linear discriminants. Now remember, in nature, in the real world data, not all problems are linearly separable. Now, first of all, let me just answer one thing. The sigmoid output basically is interpreted as probability of positive class. So what's the range of sigmoid outputs? So it's basically bounded between 0 to 1. So if it's a binary classification, binary means
Range of 2.
0 to 1.
2. Yeah, binary means basically 2. So if it's a binary classification, if you happen to know the probability of class 1, do you know all? Do you know the probability of other class as well?
Yes, total will be 1, so we can.
Yeah, exactly. So the idea is probability of class 1 plus probability of class 0 needs to be 1. So if someone tells me the probability of class 1, then probability of class 0 is okay. Remember this linear hypothesis? There's also transpose here, but NumPy and all these kind of matrix libraries will handle without doing the transpose anyways. Okay. Okay, fine. So this is the hypothesis of linear regression. If you think about what am I really asking you is, okay, let's say here is x1 and x2. I'm really asking you this question and try to understand this. There are two groups. What I'm asking you is to draw a straight line. Now tell me which is the best straight line. Tell me to stop. Which is the best straight line?
That passes between the two lines, right? Between two red and two black.
But isn't all the three lines are doing exactly the same thing?
But in one case, you know, one point is very far, right? If it's in the case of yellow, red lies very far. No, I mean, just a second, very close.
Again, this is the same problem, right? Earlier we had the problem which is the best line, which is the best fit line. Now the problem is which is the best line which divides the groups, right? In regression, you had the problem that which is the best line of curve which goes through or fits through most of the data. Now here's the problem that between two or more groups, which is one or which are multiple lines which divide the data the best, right? Isn't it something similar that, okay, if you regress the line properly or the curve properly, you might get a dividing area or dividing region properly?
We can focus on the residue of for the data?
Residue, very good. So you want to focus on the residue of the data. Now there is a small problem, although you can go around with it. Now the problem with residue is, anyone knows what a residue means?
No.
Didn't we like cover this small part? So if I'm not y bar is the average. Okay. Now the problem is, how will you calculate this mean thing? Hello?
Yeah, you mean the error or?
No, just the residue. If you want to get this residue, so you need to get something called mean. Okay, why mean? If there are two classes, something called true and false. Okay, how do you get their mean exactly? Because it works for discrete classes, and discrete classes could be simple labels or something. They might not exactly be numbers, although you can interpret them as numbers, of course. But what if there is no direct interpretation? Then how would you solve this? Because you would not get the y bar overall. You can get y, you can get a y hat as well. But what about y bar?
Is it like, with frequencies? Because when it's category, we usually do frequency, right?
Frequency, but then you will have to apply maybe distance tree might have been a better algorithm, but in distance based, how will you do it? Once you go in probability, then you cannot do the distance based thing at all. Here you want to do something with distance based, or maybe trying to understand in terms of where is the better probability based on a line. Once you already go in that probability space, it would be very hard to interpret it as lines or curves which are dividing two areas. So how would you do it? So one idea is that why don't we push this? So when you are dealing with S of theta, so let's construct the logistic hypothesis. Now this needs to be slightly different. So logistic hypothesis, again, it will be represented by S theta, but it is what does it mean? Or do you understand what did I just do? What would be the output of this logistic hypothesis? Come on.
It is sigmoid function.
It is sigmoid. I just asked what is the output. You are right about that. But what is the output?
You mean
It will 0 to the
probability?
1. It will be 0 to the 1.
Very good. So the output will be somewhere between 0 to 1. So it will be interpreted as probability. Am I right?
Yes.
I might be thinking why I'm taking this turn all of a sudden, like why I'm going in this direction. Because there is a very interesting phenomenon that is going to happen right now. Okay. Basically, you will solve classification by doing regression. Okay. So basically, this is basic idea. Okay. Okay. Let me ask you a very simple question, and this might be very basic, but okay. I want you to look at the sigmoid function. Okay. So because it's a binary classification, assumption, we see that sigmoid, the input is positive, then we get value more than 0.5. So see, in this space, when the input is positive, you have value more than 0.5. So can I say when input is positive, the class, let's say all the probabilities, okay, anything greater than equal to 0.5 is class 1, and else, try to imagine it as if or else. So whatever the probability else, whatever the probability lesser is, it means class 0. So tell me, to attain class 1, what should be my input value? Basically, if someone is
0
asking
to
me,
45.
sorry.
Greater than or equal to 0.
Very good. So x needs to be greater than equal to 0. Everyone is clear why? Because of this. 0 is 0.5. You can do this, it's not very hard. So you can put the values. Tell me the output. Everyone agrees? So fundamentally what we are saying is that this whole equation for class 1, let's say class 1, when your whole equation is greater than equal to 0. Now tell me, what is theta xi exactly? Or the summation sign, what it is exactly?
The equation of linear line.
Perfect. When, although if you're saying line, then maybe don't say linear. It is going to be linear. Okay. Yeah, that's a very good interpretation that you just had. Fundamentally, this equation is linear, right? Theta I dot xi. It's linear hypothesis of your linear regression. So it means it is a line. Okay. Everyone must have solved some equation like, okay, I will just make it very simple for you. So let's take this equation as theta 1x, okay? Or if you want to take it as mx plus c. You understand what does this means? Or okay, let me ask you this. What does this means? Or maybe sorry, my bad. What does this equation means? Can anyone tell me?
Line with slope m and intercept c.
Perfect. It's just a line with slope m and intercept c, right? Now line has only basically one dimension. Okay, it just has length, it has no width. Okay. Now tell me this one. What does this mean? Or maybe, sorry, let me put this one just to fulfill the whole thing. Can you tell me what it is?
Points on line and above.
Sorry.
The points on line and above. So you
Not
did
on
you
the
do?
line. Okay, not on the line because I did not use the equal to sign.
Oh, sorry. Yeah, not on the line. Yeah,
Very
only
good.
the above points.
So rather than means points are okay, or you can say reason. You understand the shading style, right? Basically, it just means in that region. Now from this line, upwards of this line, there is one region, and lower of this line, there is another region. So the idea is very simple. In this upward area, red points live. In the lower area, blue points live. Doesn't it came as a very good classification? See what this line did. By taking this greater sign or less than sign, you do not come up with a line. Actually, you come up with two reasons. One reason you can dedicate for class 1, which you can see by the probability and the greater value. The other is the lower value, which is lower than that, which would be the second class, let's say called class 0. Okay. By doing this, you have basically divided the whole space into two areas or two regions. Okay, so basically any classifier based on a single line is by default binary classifier. Why? Because a single line or a linear discriminant can divide the overall area in two spaces only. Agree? Line divides the area in two regions only.
Sorry, can you please explain again? I'm just a bit
No problem.
confused.
Okay, imagine the equation of line. What is this? Now, based on the similar idea, can you tell me what is this? And similarly, what is this? So if I were to draw a line, let me use this. Can I say this equation is yes or no?
Yes.
Okay, very good. Now, can I say that the region above, the whole region that is above this line is nothing but mx plus c minus y is greater than 0?
Yes.
Perfect. Similarly, the lower area is mx plus c minus y is less than 0. So if you were to basically look, you want to discriminate, right? Or you want to draw a line to divide two areas or 2 points or 2 groups basically. So this is line, right? Same thing, mx plus c minus y, sorry, is equal to 0. Now, this red lies in this area. What is this area?
mx plus y greater than 0. Mx plus c.
Right? And this area is? Isn't that what we are saying all the time? That fundamentally, if your equation is like this, okay? And if you are greater than equal to 0, then class 1 means even on line it is class 1. Okay, so once you understand this, what is the actual thing you want to really find here? What is left to estimate? That's the question.
Best fit line to classify.
True. And to best find that line, what we require, what do we need to estimate? Come on, you already know this answer actually.
You mean probability?
No. Probability
cost?
is out. Not exactly. What do you need to estimate? What do you need to approximate here? Okay, do a mental exercise. What is known by us already? What do we know already? Through the data, what do we know already?
We need to estimate the coefficient of the.
Perfect. Yes, you need to estimate theta because that is the unknown part. Isn't it the same problem as what we had run into linear regression? That we wanted the theta, right? So you had the hypothesis, but you did not know the theta. So if you again start with the same assumption that, okay, the discriminant is a line or a linear system. So even your hypothesis is slightly complex, let's say. But if you see in the if you see in this equation very carefully, what is the variable exactly? Okay guys, what is hypothesis?
It has two parameters, right? Q0 and Q1.
Yeah, no, simply hypothesis is mathematical assumption, or you can think it as mathematical function. Okay, so you are assuming that the line or the overall sigmoid is like this because the sigmoid hypothesis is. Now tell me, what is unknown here? Theta, right? This is the unknown part. X is known from the data itself. A is Euler's constant, which is 2.718, something like this. So the only variable is theta. So basically I have to regress to find theta itself. Okay, so to do regression, what is required?
Do we need to do the cost here as well?
Very good. You will require, after the hypothesis, the next problem, once you know that you are dealing with some kind of regression, you need to start thinking about the cost function. Now, what cost function should I take?
Is it here squared MSE or M?
Yeah, a person, even when I kind of read this topic first, even I thought, why not MSE? What is wrong with MSE? Of course, we can go with MSE because I am getting probability values that appears to be continuous. But there is a problem, and this problem is not that apparent easily. Okay, so look at your current hypothesis, how it is. Okay, with the summation sign. Now, whenever you see this E, okay, ever exponential, there's a generic advice: do not put power over there. This is a very bad practice, not bad practice, means it will make your problem very complicated after a while. Why? Because, okay, do you remember what happens when we put power? Means effect, do you remember the effect of power? What happens to the curve exactly?
It increases, right? I mean, the lowest
The
points.
the complexity increases, so it basically becomes much more curved. So the problem is, and let me show you through the slides because the drawing might be slightly better here. Okay. Instead of mean squared error, we use cost function, call it cross entropy or a log loss and average time. Cross entropy loss can be divided into two separate cost functions, one for y is equal to 1, one for y is equal to 0. Why? Because what will happen is squaring a sigmoid function like this, wherever you see this E kind of thing, is not gonna be easy because it will give you a rise to a something called a non-convex surface, which doesn't have like just one minima. Okay, so far you were dealing with these very cool figures where you knew there was only one minima, so it was always easy to solve. In non-convex, that's not going to be the scenario. So to figure out the global maxima, so these are like local minimas. Okay, these two are local minima, and this is a global minima. So your task is to roast to global minima, but what will happen if you get stuck here? You can get stuck here, right? Because the derivative will become 0. Then why would you move forward? So the idea is you will not get the best answers. Now, why it is happening? Again, the same idea I will give you. If you ever have this kind of problem, so let's say if you have exponential or something, let's say like in this form, and if you put a power over there, 2, 3, 4, whatever it is, what it does is it just makes the whole curve much complex than previously. So what is the inverse of power?
Log.
Very good. Always remember this. My professor used to say, whenever you cannot solve a problem by using power or it becomes more complicated, always put log on both sides. It usually tends to solve the problem. And that has worked for me as a lot actually. So use logarithm. So rather than sticking with mean squared error, let's take something called log loss, which is referred as cross entropy. Okay, can someone tell me how does log functions look like? You can take any base, it doesn't really matter to me. Log e of x, how would it look like?
Just increases just like a nonlinear function.
I would like, I would want a better answer.
I can draw it. So.
Yeah, that would be a problem. Yeah, okay, I guess you're right. Does anyone wants to take a gambit? That how would it look like? Okay, let me give you an answer. So it's a simple idea. You can take any example. Okay, just think log 2 of, start doing the math. Log 2 of 2 is
1.
Very good. Log 2 of 4 is
2.
And similarly, you know what is going to happen here. So if I were to draw all this, so now imagine this is x, okay, and this is y. So now this is log 2 of whatever x. This is your y-axis and this is x. So the growth on this axis is going to be much slower rather than the growth on this axis. So if here is 1 and here is 2, so for 1, what would be the answer? Anyone?
0.
Very good. So on. Basically, if you take 2 to the power 0, it basically becomes 1, right? So basically, if I take log 2 of 1, basically the answer is 0. All right. Similarly, now here is, so this is 1, this is 2, now this is 4. And by that gap 8, and that by gap 8, 16. So I'm just giving you simple tips how to plot these things. So for here it is 0, for here it is 1, let's say this is 1. Now here it is 2, so that this gap is uniform. And this is 3 and 4. The problem is this gap, right? And you will see after a while it will like to flatten out because you will require a lot of change in this axis to make even a small change in this axis. So this is how your log of x is gonna look like. Okay. But you will see something very funny, and that is what I'm gonna explain to you after a while. Okay. So first, let me give you the basic idea that what kind of cost function you should use. So the cost function that we are going to look here is, because it's a binary classification, we will call it binary cross entropy, or some people like to call it binary log. Same thing, okay? Doesn't changes anything. Now the equation for the, now it will be again defined in terms of j theta. It will be minus 1 by total of number of n, because you have to average after all, summation. Let's say it is called 1 to m, so that it is total of m. And let's take the value. So you will have to take how much? So you will have to first take the label. Let's call it y, yi, whatever the exact label is. Now y could be, let's say, because of binary classification, it could be 0 or 1 only. There is nothing else that can happen. Then you take a log. Now this is y hat. What is y hat? Output of hypothesis. Basically this, you remember this equation? Basically this is your y hat plus, again all of this is in the same one, of course, 1 minus y I I will explain why both equations are required. Log, and in information theory we usually take 2, but in natural log you should usually take n1 minus y hat. This is the complete equation. So rather than doing this, because my writing might not be very good, so why don't I let you write the whole thing? So this is the whole equation, guys. If you want to write it down, it is a good time to write the whole thing.
Is this log to base 2, the one you showed in the question?
Okay, so basically these ideas come from physics, right? So if you read any kind of physics book, it will be like log E. But because we are in computer science domain, we will consider log 2, okay? Okay, all right. So this part of the equation is only valid when y is 1. And this part of equation is valid when y is 0. I will explain how this idea works. Please write it down and I will explain you. Now what happens when you apply log is based on a sigmoid or something, you get like these kind of curves. When y is equal to 1, this will be the curve, and when y is equal to 0, this will be the curve. Basically, when you apply a logarithm, you get a smooth monotonic functions. Monotonic means either increasing or decreasing. It's always increasing or decreasing. So the function is either decreasing or always increasing the way you look at it, which makes it very easy to calculate the gradient and minimize the loss. Okay. So let's look at the y is equal to 1 formula. When the actual y, now y means actual y, actual result, right? So what did I just say? 1 minus m summation of, so only this part will be active, the other part will become 0, and you will see y. And then you take a log, let's say 2 or whatever you want to take, of output, so whatever the output of y hat is. Now tell me, if y is equal to 1, so you have to literally write 1 is equal to here. Okay, so you will take minus 1 by m into summation of all the points for, now y is 1 here, okay, remember this part. Now log 2 of, okay, you want to take log 2 of y hat. Now y hat is what? Some kind of probability for you, okay? So let's say y hat is 0.9. Now tell me the problem. What is loss here? So y actual says it is 1, but y hat says is 0.9. Do you see the problem?
So 0.1 difference, right?
Yeah, you will think that is the thing. That basically the difference is 0.1, but it's not that simple. Basically, it's based on a sigmoid curve, right? So the difference of 0.1 could mean actually a lot on sigmoid curve. That's why we are basically taking a log. Although till you are considering sigmoid, you can also imagine log E or something. Okay. So fundamentally, what we are playing at is, okay, think now very carefully. Loss should be 0 when y is 1 and y hat is also 1.0. Agree? Let's look at our equation. Does it works like that? Minus 1 by m, it doesn't matter right now. Y, so this is 1, so this will become 1 dot log of log 2 or whatever you want to take. See, the overall loss becomes 0. If I were to take the whole equation just to make sure that everyone is on the same page. 1 dot 1 came from y, remember this, okay? Log 2 of 0, sorry 1, sorry, plus, because everything is gonna get added here, 1 minus yi, so 1 minus 1 is 0, plus log 2 of 1 minus 1, okay? Now it doesn't matter because this will become 0, so the overall loss is 0, okay? Now but imagine j theta is minus 1, y is 1, okay? So the actual output y is still 1, summation 1 dot log 2 of, let's say some value, let's imagine 0.5, okay? Because it is easier to calculate, that's why I'm taking, okay? Again 1 minus 1, so this part becomes 0 anyways. So whatever you have, 0.5, let's say, it doesn't matter because this will become 0. So now the loss is, forget about number of points, let's worry about 1 point. So log 2 of half, how much it is? And there is a minus sign, of course. How much it is? Anyone can tell me? How do you solve for these kind of problems? It's a simple trick. You can do log 2 of 1 minus log 2 of 2. So you will come to know basically
1.
overall, basically you will basically get a negative sign, but this negative sign will basically get cancelled out and you will get a loss of 1 for 1 point. Okay, so you were to predict, let's say 1, but you predicted 0.5, means it's somewhere in middle. That is loss of 1 based on a sigmoid function. Similarly, if you were to treat for 0, let's say y is actually 0, then you will notice the first part of the equation becomes redundant because y is 0. Now whatever y hat is, I don't care, it will also not have any impact. Let's say, okay, so y is 0, what should be y hat if there is no loss? This should be 0 as well, right? So this part will actually not do any trick. 1 minus 0 into log 2 of 1 minus 0. And you will come to know this is 0 as well, which is good because you want loss as minimal as possible. But let's see, if log, again, if summation 0 minus log, and let's take this time it is 0.5, somewhere in middle. 1 minus 0 goes. So log 2 of 1 minus 5 is again 0.5. And if you do all the math, same thing, it will come, let's say if we eliminate m, we will come to 1. And you see, we get the loss again. So the idea is for based on all the points, because it is a summation and then the average, we will come to know our total loss. And whatever this loss is, the idea is because of the curve, we want the curve, right? Why? Because fundamentally we want to do gradient descent. Okay, and it will be easier to solve in either of the curves to get the lowest point, thus solving the whole problem. And funnily enough, you might not believe it, if we do the correct reduction, we come up with the same equation for the updates. Theta I is nothing but theta I minus alpha, okay, actually I should put a summation sign here, of course. See, what does it look like? Gradient descent update. That fundamentally you are tinkering with theta. So what happens when I tinker with theta 0, theta 1 at different points? Fundamentally what I'm doing is, if you think very carefully, is you are changing the line as you tinker with theta. Oh, sorry. You are getting the line to change right? I'm drawing the different lines. It is based on the regression itself. That these lines are developing based on the theta. So whatever the theta value changes, let's say whatever the change in theta 1 plus theta naught happens, it changes the y value itself. Now this, and now by understanding this idea that basically any region which is in this area, this will classify the overall area into two areas, and thus giving you the classification boundaries. Does everyone understand what just happened?
So why did you choose the black line as the classical line?
No, I'm just giving an example. Okay, that's just an example. Okay, you can have any other line as well. I'm just saying that let's say at some point there is no change in theta. Okay, so there is no change in theta values. Theta 1 and theta naught are not changing at all. So let's say that is the black line or gray line. Okay, so I'm just saying that if the gray line is something that we settle at based on theta naught and theta 1 values, so by dividing the area into greater than and lesser than, we come up with two areas where the classifications will, or classification reason would be live. Does that make sense?
I think maybe with example, yeah, it will be better. How to say?
Yeah, that's the problem. Okay, let's take an example, or let's take an idea. Let's go step by step. Okay, now we have an example, unfortunately, but it will take time to solve. Okay, so basically this is the idea at some point, that if you figure out a correct line or whatever the line is, and if it is greater than or equal to 0.5, then basically it is spam or not spam. So if you want to solve something like this, or something for some value, basically you want to get the hypothesis to be positive so that you can identify class 1. Okay, so something like this. Basically you are trying to identify that, let's say you come up with a line and you want to figure out what this point is, which class it belongs to. Does it belongs to the red points or the blue classes? So basically you have to figure out the line first. Okay, let's say 2 minus x is equal to y is equal to the exact line. So over there theta naught, if you look, is 2, and theta 1 is basically -1, sorry. That has to be figured out so that you can actually even do this prediction. So based on values of, so let's say the red ones are 1 and crosses are 0. So based on that, you will need to figure out where the classification belongs to. So let me try this in one way. So look, fundamentally what I'm saying is, based on the probability outputs, okay, because that is what your hypothesis is outputting, you have to regress a line fundamentally. So okay, first let me draw these points so that it is easier for us to visualize. You can see there are two groups, right? Now let's say I start with this line. Okay, let's say the loss value is really high. Then I regress and I get something like this. Okay, then I regress and I might get this line. And I might regress a bit more and I might stop at some point. Let's say this blue line, or the light blue color line that you are looking ahead at, seems to be the best fit line. Best fit line. to divide. But how do you think we reached here? How does it comes, or how did we reach to this line? By continuously updating theta naught and theta 1. Let's say the equation is very simple right now. So by doing gradual updates, how both of them have been updated? By gradient descent steps. Okay, summation of y hat minus y and theta 1 is alpha 1 by m, summation of y hat minus y, let's call it x. If you keep updating theta naught, theta 1, similarly in the style of your linear regression, you will keep coming up with these lines, and at some point one line or some line approximation will make a very clear-cut distinction where the probabilities are equally well balanced, where there would be two reasons. One would be the greater than line area, one would be the lower area. And if you see there very carefully, the greater one area contains all these crosses and the lower one area contains all these stars. Is it clear?
The green line also classifies the data, right? Then
Again, that's not the fight, okay? That's not the fight. At some point, based on the maths based on the maths of the regression, at some point you will find a line which would be kind of dividing the both of the groups in a best fit manner as possible. You can again think about this. In linear regression, you can come up with also a line which looks approximately the same, but based on your cost value, you determine this might be the best value to work with. Am I right or wrong?
Right.
Yeah, same thing here. You don't have to worry about this part that green line looks better. Don't go on that thing looks or something. Okay, let's not go on there. We have to just do the maths and then the computer will take care of it. The idea is you keep your maths correct. Computer will solve for it. You don't have to visually rely on anything here because you cannot manually calculate all the distances and all the probabilities. It's not possible. So it's better to let the computer do all this work. And so the question would be, let's say let's say once you have figured this part out. So my question is, or the future question is, tell me, I am drawing multiple points, okay? So tell me which one belongs where, in which class. This is point 1, this is point 2, and this is point 3. So 1 belongs to which class? Come on, this you know already.
Cross.
Greater than equals to 1.
Okay. 2 belongs to? Two belongs to which area? Or which?
Star.
It is star. 3 belongs to? Again, 3 belongs to? Yeah, very good. Okay. So this is what I was trying to explain at that point, that based on this, you can do the classification. And of course, you can take nonlinear hypothesis itself at the very start. You can maybe start with the circle itself. Is this clear? If you have any problems, please ask me.
Why is third one star?
Okay. Third one star y means I thought it was very clear. So 3 is okay. So this dot, this pointer that you are looking at, is still on the lower side of this gray line. Let's say the gray line is the final line that I decided. So if it is on the lower side, which group it will belong to?
Less than.
No, less than. I'm just literally asking which group it will belong to. Classification, right? So which group it
Yeah.
belongs to? So it will be star.
Okay.
Okay.
Yeah.
Okay, cool. Now my idea is, my core idea would be that basically you can also imagine regression just not for a linear line. You can imagine it for, means you can take a nonlinear hypothesis. Okay, what is the hypothesis? Would be for a circle. Basically it is usually a radius or n, some value basically. Okay, whatever we want to imagine. So we can imagine that basically this equation is nothing but s theta. I'm just first imagining the equation of the circle. Plus some theta naught. Okay, this x naught 1 square, x naught square is 1 basically. So that is not going to change. Does this look like equation of circle? If yes, if it looks like equation of circle, so again you can put this equation of circle into a sigmoid equation, and you could work like 1 plus e to the power minus, again you can put it very easily, theta I into xi square, where it goes from 0 to 2. Okay, and this basically comes up like a circles equation, and basically by manipulating all the 3 thetas you can come up with a proper circle which bifurcates, let's say, this kind of a non-linear classification. Maybe this is a better circle. Okay, you start at a circle, but then you can get a better circle to kind of bifurcate both of them, both of the areas or both of the reasons. Okay, now you are still left with one problem. Then by that logic, you can only do binary classification, right? Because a single line or curve can only divide in 2 regions. Am I correct? Then how do you solve for anything greater than binary? It's what you have a multi-classification there.
Log of 3 maybe
Log
greater
of
than 2.
change, no, but look, your equation or the binary classification, look, fundamental idea is theoretical problem, right? If you only draw a single line, you cannot have a multi-classification.
No.
Let's say, think, your outputs are vegan, vegetarian, non-vegetarian. Now think, How would you use a logistic regression here? You know, actually, till long time, logistic regression was not used for multi-classification. People would only use for a binary classification. Of course, people developed a technique by using a simple idea, basically, and now it can be used for your multi-classification as well. So what would be the most simplest technique to solve this problem? That is my question to you. Zero, one color. I did not get what do you want to say to me? Zero, one color. I'm not getting it exactly. Okay, let me
Take
give you
two
the
data sets, then combine them to.
two data sets. Okay, very good, very good. It is called one versus all. Some people call it OVA, or some people also call it one versus rest. Okay, so mostly I personally like OVR, one versus rest. So what is OVR? So idea is very simple. Okay, imagine you have three classifications. But you want to do a logistic regression. How do you do it? It's simple. First, you cover this class as your primary or positive class, and you draw a line reducing this one as single class and the rest two as another one class. So means treating them binary one by one, then treating these two as one and this brown one as a separate class, and similarly treating these two as one. Now by combination of these three lines, okay, so tell me what will happen when I put here, which class it belongs to. Let me show you.
The brown class and the.
Okay, first let me show you so that you can imagine this. Imagine all three classes, class 1, class 2, class 3. So it's a multi-classification. Everyone is with me?
Yeah.
Okay, so now I start doing this. So first I develop one hypothesis where the red one is positive class and the both blue ones are the negative classes. Okay, so this green line is your h1 theta. Okay, because this is treating the red one as positive and rest all of them as negative classes. Similarly, we will do the same for one another. Sorry about this color problem. Imagine this is your positive class, this is your positive class, and rest of them are negative classes. So this is your S2 of theta. Now this is not a power, this is just a representation. Okay, so you are coming not with one line, you are coming up with three lines. Okay, let's say you get three lines, and what do? You run individual logistic regression for all three hypotheses considering one class group as positive class. You calculate probabilities for three such hypotheses, and the final output is very simple. How do you know which class it belongs to? You take the max of all the three. Whichever is the max, that class it belongs to.
Say it again.
Yeah, that's it. First, you run three or as many logistic regressions internally by using different hypotheses where one class is positive class. Now you will get three probabilities, let's say, for one next test output. So you will run a max of all the three, let's say it's a simple one, don't worry. Let's say in this case scenario where let's say some kind of triangle is formed and you are trying to find the which class it belongs to, this cross. So for all the three ones, basically when you will pass it as a test argument, you will get a probability value from, let's say probability 1 is 0.7. So it belongs to which class? Simply you have to do a max. What the max function does, it returns you the highest value. Okay, so it belongs to class 1 because the probability is the highest. Any doubt? How did I solve this? Look, once you develop all the three hypotheses, let's say for this point you want to find it. Now you understand it is in kind of a middle zone. So how do you know which class it really belongs to? Okay, so fundamentally what you need to do is, with respect to all the three lines, you need to get the probability, means the output. So let's call it P1, let's call it P2, and let's call it P3. So you will get three probability values, right? So maybe P1 outputs some value, let's say 0.3. Maybe P2 in outputs 0.4, and maybe this outputs 0.45. Now there is no constraint, they have to be equal to 1, okay? So you apply max. So which class it belongs to? Let's say this is P3, so it belongs to class 3. Let's say this is a class 3. Did you get it? What just happened?
Yes, it's clear.
Is it the shortest distance, shortest tangent towards that line?
Yeah, it appears so. Yes, no doubt. It does appear so that whatever is the minimal distance, it might get it. But again, we are not relying on our eyes to find this one out. Okay, so we are passing the value to a sigmoid, and that sigmoid is returning a value, that is its probability value. Okay, so theta I xi. So theta is known. Now xi I am putting for the new test value. It will return me a probability, let's say 0.45. So now because of three lines here, you will get three probabilities. So which one to stick with? The one which is giving the highest probability, because that is what it might be the closest to. The interpretation is, of course, it must be closer. That's why it is giving you better probability. But we are not doing a distance calculation. Remember this. That will come in other algorithms, not in this one.